So once again, you are practically welcome to how to apply regression and correlation. Okay. Now we are going to take the Brukutu data set. This is a typical research with titles that I'm going to show you and how you should go about in your normal thesis writing. It doesn't matter whether it's undergraduate or master's or PhD. The information here is relevant to all levels, even to people who are academics and who are writing journal articles. Now let's assume that you are writing a journal paper, and this paper is entitled Determinants of Demand in the Alcoholic Beverage Industry in Ghana. I just made up the title. And then your focus is the impact of location, occupation, and religion. Now we've already given previous reasons in the previous videos on why you are looking at these variables, location, occupation, and religion, justifiable reasons, and why you believe your research might be good. The structure might be like this. Whether it's a paper or a thesis, you will need to put down the abstract, the introduction. Okay. Inside the introduction, you will justify the background, the contribution, the gaps, okay, the research objectives and questions. Okay. You would have indicated all of that. Then you go to your literature, you indicate your theoretical review and your empirical review. And then the methodology, which is what we're about to do, comes in. Okay. You may have to include other methodologies in addition to what we are going to do, or justify some of them. And then you show your results using some beautiful works in R, which we shall do. You discuss the results, validating it, cross-fertilizing it with other studies results in the previous literature, and then concluding and citing your bibliography. Now, this is where you come to the methodology section. So what I'm going to do now is I'm going to do what we call a simple regression. A simple regression of the information that we have. So the first thing we are going to do, which, depending on when you watch this, you would have actually done it already. The simple thing we are going to do is we are going to load the data into Excel. And load the data from Excel to R. So let me just take you to Excel to watch the data set. So this is a data set. You can see the data set is here. Quantity, price, complement price, income, location, occupation, and religion. Okay. That's a data set which we are taking into R. Now, normally when you're taking this data set into R, you do Control A to highlight everything, Control C to copy, and then you open your R. So let's go and open the R. And this is the R that we have opened. Okay. Now, this R that we are opening, this command that you see here will do the trick. Let me see if I can give a bit of a magnifying glass to help us to be able to catch what we are discussing here. So if I should zoom in a little, this is a command that I'm interested in. Every other thing is an instruction. Okay, so this is a command. So with the data copied, you run this command, something we've already done in the previous work. Now when you run the command, come down here, you see it shown there, which means that the data is what? Is loaded. Now for you to see that the data is loaded, just highlight and double click only the GIN, G-I-N, which is the name of the data we gave, and just enter, and you come down and you see that the data is nicely loaded into the R. Now, in the previous lecture and the videos, we looking at some summary statistics in the data. I'm jumping all of that. I'm going to where we are going to do just the regression. So this is a simple regression that we are doing. Let me zoom it slightly again. So this is a simple regression. And what I am doing here is that I am plotting. I'm going to plot the quantity demanded with a tilde sign relative to the price. So I'm just looking at the quick relationship between the quantity demanded and the price. Now we know theoretically, a priori, that this is supposed to be negative. but I just want to plot it to see. I want the color to be blue, the line weight to be 2, the name of the data is Jim, and I want to give it a title. Okay, I'm calling it scatter plot of quantity and P and fitted line. Let me write the fitted properly. And then I'll add an outline. Okay, the outline is the fitted line. Okay, so I'm going to scatter plot it with this information here, and then I will add an outline. The outline is the fitted line, the regression line. So I'm putting all of that, together right here in this command. So I'm going to run that, and I'll show you the result. So let's run it. Boom. Now, once I do that, for me to be sure that the result is there, I come to the right-hand side of the information, the table here. And when you come right side here, you will see a clear information that we've done. You will notice here that that's the name of the title. We have the scatter plot scale, blah, blah, blah. And let me just zoom out. And you can see that the regression line is telling us that there appears to be a negative relationship between price and quantity demanded. The quantity demanded is on the y-axis. Of course, you could come to the x-axis, no problem. Okay. And there's a negative relation between quantity demanded and price. And the regression line, which is the red line, is hovering around, the scatter plots are around it. Okay, so you've been able to do that simple regression line, which gives you a fair picturesque, idea about what is happening. Now let's run the regression analysis. Let's do the regression itself. Okay. Now, I'm taking you back here. If you want to do the regression, we call it Gene Simple. Because we are doing simple regression, we do it Gene Simple. It will use a package in R, which is known as the LM package. The LM package. The LM package, where you regress the dependent variable on the independent variable. The dependent variable is Q, independent variable is P with a tilde sign in between them. You indicate the name of the data. You bring a semicolon. Everything is important. Everything is important. You bring a semicolon, and then you indicate the summary of the results. So that will regress the Q on the P, the Q being the dependent variable in the linear model, and then it will give you the results. And then we are now going to interpret the results, okay, once we get them. So let's go to R and then run that. So that means I need to type the command I just have here. So we go to R, and then we run this command. Now let me show you how you can do this whole command. So in this command, I have it here, command number 88 here, highlighted, Gene Simple, LM, blah, 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 blah. You can put a cursor there, anywhere there, and then run it. Okay, everything that I said, you just run it. Make sure your typos are all corrected. And once you run it, you come down here, you see the results in the console. Watch that. That's a beautiful result. Eh? The results is indicating, okay, that there's a formula which is quantity demanded on price. We have the residuals. You remember in a regression, we'll get something called residuals. Okay, I'll come back to that pretty soon. And then you have your coefficient. Of course, in this context, the only coefficient we had was price. Okay, so the only thing that you see here is this price. Okay, that's the coefficient there. And you can see that there are so many other things that is inside there, which we will make sense of pretty soon. Okay, the first thing we want to talk about is the coefficient, which in R is known as the estimate. The estimate is negative 14.26. What does that mean? It's negative because there's a negative relationship between price and quantity demanded. So you can see that clearly there. Okay. So what this means is that if there is an increase, remember price is a changing variable, it's a numerical variable. If there's an increase in the price by 1 unit, quantity demanded will fall by 14.26 units. That is what the estimate means. Okay. Now, what is the standard error? Well, the standard error, we know it in the regression, and we always know that the estimate divided by the standard error will always give you the t-statistic or the t-value. Keep that in mind. The estimate divided by the standard error will give you the t-statistic. Okay? And from the t-statistic, normally when you go and take a table, when you take a table and the t-table, you go and read this t-statistic there, you can find the p-value. The p-value is the last column here, which is a probability greater than the absolute value of t. So that is the p-value. And whenever the p-value is less than 5%, it means that the estimate is significant. It means that that independent variable is statistically significant in affecting the dependent variable. Now, if you look at our own, it is 0. Because you have 5.25, e minus 13, or e minus 13. E minus 13 means there are about 13 zeros before the 525. And it is statistically significant at 0.1%. How do we know? Anytime you have triple star, it means that it's significant at 0.1%. It's significant. It's so significant. Okay, you know we have 1% significant, 5% significant, 10% significant. Now this is 0.1% significant. So it's very significant. So it means that price significantly affects the quantity demanded. Okay. Now the other interpretation will come there when we bring other ones. Okay. For example, the residual standard error. Okay. The same way we have the standard error here for each independent variable, we also have the residual standard error. Okay. We also have the multiple R square. We'll come to that and explain it when we get to the multiple regression. The adjusted R square. The adjusted R square will always be lesser than the multiple R square for a reason we shall know very soon. And then finally, the joint test significance. Okay. We'll come to all of this. For now, what we wanted to understand is that we wanted to know that in a simple regression like this, price significantly affects quantity demanded. This is a beautiful way to look at that. But that is not all, because you see, the thing is that there's one thing identifying the significance of the thing. But this is just a simple regression. Everything that you see is just simple. The next thing the analyst want to do is to go beyond the simple regression. Go beyond the simple regression. And we will look at that.